So I'm here today to talk about Barrel, to present Barrel, but also to present how I'm making a sustainable business model about making it and still keeping it open source. So Barrel is a project that I started a long time ago, and I thought that I didn't present it really well. And to be honest, I would like to redo that slides too, but it's too late now. So let's present it the way that now. So we will see today a quick introduction of who I am, the context of why I created Barrel, what is Barrel exactly, what are the features of Barrel, its usage, what you can do with that, and why Erlang was a perfect fit to build such database. And we will see a new open source model, maybe not that new, but at least something I find quite innovative. So just to quickly introduce me, so I'm the founder of Enki Multimedia. I own my own company. I founded that some years ago. And I maintain a lot of open source projects. Among them, you may know in Python, you may know JUnitron. In Erlang, you may know Hackney, Erlang rocksbd, and other databases. I was a core developer of CouchDB also, stuff like this. And I'm doing my living about doing consulting and developments inside Erlang C and Python's code. So I'm one of the founders of the Erlang Foundations and actual members. And my company is also sponsoring the Erlang Foundations. So why I created Barrel? Mostly, so first I wanted to have something very customizable, because this is what I do for my customers. I'm doing some custom data storage, because their business wants to have data storage, and I was tired about using URM or doing abstraction over SQL or stuff like this. And this is why I started first to hack around CouchDB. Then I forked CouchDB to add some feature for my customers. But then I was tired to just having 200 forks and having to make things upstream, etc., etc. So I started to build some years ago Barrel. This is first to feed the data to the business of the customers, and as a side effect, we see also that more and more people going out of the cloud today, at least a lot of corporates going out of the cloud, some for money reasons, some more likely because they have some privacy concerns and legal purpose also, because as you know, the main cloud are US clouds, and for some European companies that it's an issue sometimes. And so they are thinking to put back the things. And as we saw yesterday in the talk, being on the cloud is very expensive over the time. So it may be good when you want to make an MVP going fast on the market, but over the times you may have some advantage to put back the data under your controls. I also wanted something relatively new, something I like in Ceph and other very low-level storage. I wanted to separate the control plan from the data storage. We will see later. I will focus on that a little later, because then it give you more flexibility. You can extend the storage as you want to, and you can expand the control plan and customize the control plan if you want to. And the control plan is basically how you query your data, but also how you show your data, and how you can expose the data to your own applications or your customers. And I wanted to build something that allows me to create, or that allows you to create something more custom to your data, to remove any abstractions like the ORMs, or simplify the business. You wanted to, without compromising with the flexibility that you can have with, when you are using a SQL database. So what I mean by separating the control plan from the data plane. So first, you can imagine to have, there are two main structure inside Barrel. There is the data nodes, The data node is only storing the data on a local storage, and it does that. It can encrypt the data on the data storage and just expose the metadata needed for the queries. All the indexes are created locally. So, and then over that, then you have the monitor nodes or replicator nodes that are querying the data storage, and on the monitor nodes, then you can put some applications you want to. You can create some data layer. So, if you want, for example, build an object storage over that, you can build your object storage on your monitor nodes and decide which kind of distribution you want to. For example, if you want to keep it peer-to-peer, mainly peer-to-peer, so having one node in one office, another node in one office, then you just make the data store, you just create a data store in each office. And on the monitor node, you set up rules to monitor that things. You can have many monitor nodes. They can be clustered. They discuss between each others in a peer-to-peer manner. And using that, you can build your query. But if you want to do something more to have more, how do we say? To make sure that your data is stored once and to make sure that your data is replicated in a consistent manner, then you can set up at the monitor level a raft consensus. You can create small words between your data store, and then build something more consistent. Everything is flexible. You can also mix, you can build a local cluster between multiple nodes and just build another node on one office, discuss between the cluster and that node using peer-to-peer, and in the cluster using Raft, or using something else you can build on the monitor node at the data level. Everything is customizable at that point. And I will explain later how you can do that in Erlang or in other languages. I wanted also something that fit your data business, which means that right of now you have two ways to store. Generally speaking, if you accept Foundation DB, which is a little like what I'm doing, you can store your data in a SQL database and query that data using SQL. And then, generally speaking, you will set up an ORM over that. And over that ORM, you may need also to set up a GraphQL database systems, and then you introduce more and more layer. And so what you can do with Barrel is simply have your data storage on your data storage that are stored as an atom, a sequence of data. Basically, this is stored as a graph. And you can build any model you want over that. So in your data storage, if you want to query object storage, you can do. If you want to build those, like I did for some customers, you can. If you want to make a SQL data plan over that, you can build your SQL data plan over that if you want to, or you can do whatever you want. If you want to just build a simple shop with just some fixed queries, you can also do that. And that will be simpler, maybe not over the time because we need to scale, but at the very beginning, this is very easy. And for that, you can also decide to persist some views of your data on your system, but also set up, because the control plan is external, you can, yes, there is some application in Barrel that allows you to create dynamic indexes. So it will discover over the time the data that you query no more and build the indexes for you. So just like a SQL database does, in fact. So you can query that more efficiently later. So it doesn't compromise with that much with SQL while keeping you some flexibilities you need to. And then it allows you to optimize everything. to summarize the feature that you find in Barrel, so you have a multi-model data stores. You can extend it so at the very basic level, this is only Erlangs, you don't care, everything is automated, the data node is something quite fixed. If you want to, you can hack it because it's open source, but you don't have to. Everything normally happens on the monitor nodes, on the application nodes also. And you can extend it using Erlangs, just a simple application that you start in your Erlang release. So you build a custom monitor nodes that start some applications that you will query. There is a main application that provide, that is always available, that provide an HTTP interface. So you can use that to create an HTTP interface to your data. But you can add anything, and you will find in my services also GraphQL, something that is actually written. But you don't have to make that in Erlang. So from time to time, you may want to do that in another language because you will have more features in that language. Like if you want to add some artificial intelligence or machine learning, like we say, or something like it, you can decide to write some custom function in Python, compile them at WebAssembly, sorry, and upload that function inside the data node, the monitor node, and then it will be used just like any serverless applications. But that are just simple functions that are using the data storage as a persistent store. Like I said, there is a flexible distributions. You don't have to choose. At the very beginning, you have the monitor node querying the data node. You can decide to query multiple data nodes at the same point, at some points. And you can decide at that level which level of distribution you want to. So if you want RAF consensus, you can use the RAF consensus, which is available. If you want to just use peer-to-peer and discover the data between the nodes, you can create queries that will query each node to discover the data. Or you can also decide to build a traditional cluster if you want to. Something that doesn't exist yet, but this is something possible at the end. So it's already used in production in some places. And what I'm doing now is open sourcing everything because this is 1 year or 2 that I didn't open source the things, but it has been tested a lot with a lot of cycles, demo cycles around. Yeah, I already said that. So everything is built in Erlang, so I could have chosen since to switch to something more trendy like Rust or maybe something like I'm interested in the Ziglang because I like the syntax, I like the capacities that you have in that language to build some concurrency, which is easier than something that you can do in Rust because there are many libraries you have to choose in Rust to do that. This is built in Zig somehow. But I always think it's more difficult to do that in other language. In fact, let me share the checklist I had when I built that. I wanted something resilient, something able to resist when the node crash, because crash will happen. Whatever your testing suite is good. Whatever the use case you put, even if you do proper testing or whatever, it will crash at some point. So you have to be resilient. You have to be able to ensure that your data won't be compromised because we are speaking about the data. And so you wanted something, you want a framework that provides you the safety you want in the language, something that offers the OTP Erlangs as a framework. I wanted also to build something very quickly, or at least that allows me to test different concurrency model. And I didn't find anything as easier as Erlang as of today to build something that can span some some runtime, some executions over the CPUs on your machine, or to be able to run as many processes you want to interrupt the process, etc. This is very easy to do that in Erlang at the end, more easily than having to talk about asynchronous API like it exists in Rust or in C++ today, or do something like, or even Go, where you have to make sure that your channel is not blocked, that you have to create all these queuing facilities that you have already with the process in Erlang. I will say you can build that, of course, with the channels feature in Go and stuff like this, with the send and receive and other features that are provided by Go, but this is more complicated to do and more difficult to design time. And I wanted also to be able to build something very quickly, at least at the proof of concept, that can distribute the data between machines, that can at least orchestrate the distribution between machines. And for that, you have the Erlang distributions. And I wanted to have efficient storage too. So how you can do that in Erlang? So resilience allows to build a program that can crash safely. So in Erlang, you have the supervision that is built in. You have two kinds of supervision. You have the supervisor, and you have the super supervisor, which is the application's handler on the node. And the application handler allows you to monitor the application, load the application, stop the application, upgrade the application over the fly. So that's pretty funny to play with, and you can build something that is able to restart your process if it crashes, or to make sure that you terminate your process more easily, which is very important. So closing a database is not like closing any stateless program. You need to make sure that your data are still flush on your disk. You need to make sure that your indexes that were running will finish before closing anything. So you want to have that, and this is very easy to do that with the supervisions. And you want also to be able to detect that the process crash, because if the process crash, then you will be able to say, don't handle the data here, keep it somewhere on another node if you want to. And this is very easy to do that. And yes, in Erlang, you also have that tiny processes which are better than threads, which allow that concurrency. When we say let it crash, this is just basically let it crash, but give me that crash notification so I can do something with that. And this is something that allows Erlang very easily with the processes. Time to market. So I wanted to think something that span process direction easily between CPUs across machines with system process. And for that, we have simple features that are present in the OTP framework, which is Gain server and Gain statem. Gain server for simple processes, and Gain statem to maintain your state or to build state in your applications. So these are logic added over processes using, at the very basic level, the proslib library. So if you want to build your own custom thing, you can also use the proslib library. But Gain server and Gain statem offered the feature I spoke. So they are able to match at events. You are able to have callbacks for the terminations handler. You can add a callback when you span a new process, when you cast a message. And this is where this is very easy to do that in Erlang, where something like in Go or with async in Rust, you will need to check where you're receiving your thing, when you send your thing, when it's blocking, etc., etc. You don't have to care with a Gain server or Gain statem or an Erlang process, because you have behind that you have that queue which is already doing the blocking and the receiving for you, which is already handling the pattern matching, so you can match the message, etc. This is what's offered Erlang today, and this is very easy to do that. And you have the Erlang scheduling also that unblocks the process when you want to, etc. And you have the Erlang distributions, which is built in, which allows you to span between processes, between machines, etc. And a good network stack. As of today, in Erlang, in parallel, I'm using Hackney for anything to send the data over HTTP. So the new version of Hackney has HTTP 2, finally. to be able to send the message with a custom protocol. And I'm using libp2p to handle the mesh and the peer-to-peer distributions. And locally, I'm still using the Erlang distribution to detect when a node is going down, when a node is joining locally in the cluster, because this is very easy to do. And in Barrel, you will find in the release a new module for the distribution, custom modules, that allows you to use different TCP paths between the things. Efficient storage. So since Erlang 23, we have .inifs. .inifs allows you to have different poolings for I/O and for CPU usage. It appeared that I built Erlang's rocksbd, which I just released the new versions today, which is a binding over rocksbd. And rocksbd is very efficient to store key values and indexes on the disk. So you have many features possible in that. Very efficient as of today also to store blobs. So I'm using rocksbd as a small layer with the file system to store the data, and I'm using the .inifs to make sure that it doesn't block Erlang, etc. So if you use, as of today, Erlang's rocksbd, it should be okay to store millions of keys on your data storage. And when you store data from Barrel, the model from Barrel, this is split in millions of keys over the time on the systems, which is pretty good. So all the checklist is fit. I don't see any reason to switch languages today at all. And when I want to increase or to bring more feature, I can just create a new NIF if I want to interact with the systems, or just put WebAssembly functions if I want to. So one of the points I think is I wanted to make the model sustainable. I wanted to make it open source. Since 2 years, I didn't make it open source because basically I had mostly no contribution really direct on the code, or I have tickets on that, and this is very difficult to handle tickets when you have to handle customers at the same time. So I wanted to find some model that works, that allows me to remove any frustration for the users of the open source library, because sometimes I have no time for you because I'm still working on other things, etc. So how to make it sustainable. So I'm a consultant, and being a consultant, I would say that when I see a company that asks for consultants to be 100% available for it, this is not a consultant for me. This is a remote worker, because a consultant is really an interface between the different customer areas and you, bringing you the skill. And if you stop it to work for other customers, you will lose that capacity to get an updated skill or to get some new feature. When you hire a consultant, don't stop it to be this knowledge to be updated. You will lose a lot from that. Or just hire a remote worker if you want to. But don't call it a consultant. I wanted to make the system open source. Open source for me is a core value because it's ensure for the user, for my customers, ensure that everything will exist even after me. Generally speaking, in the business, when you want to have that, you make sure that the source code is somewhere switch off, and if something happens, then you access to the source if you are making sure that the contract exists. So making sure that the open source exists is okay, and for me, it's also allows me to say my code is auditable at any time. So if you want to fit any legal purpose, you can audit the code and it's available for you. I don't have to do that for you myself because that audit can be very expensive from time to time. And yeah, open source is good for anyone. So how to make it sustainable? So with Barrel, I say we because I'm starting to hire people. But with Barrel, we are building a new offering that ensure the user that we keep continuing to release new versions, to release new updates, and that we continue to work over the time on the projects. We also make sure that we keep your data on-premise and private. So we are building a new platform which is hosted on our hardware, for now just in Europe, to exchange it. But since the barrel, the control plane is separated from the data plane, this is very easy. Just have some machine on the site, store the data, encrypt, just expose the metadata you want for the query and pass it over platforms, which make it more easier for you because you don't have to build the hardware or to buy the transit units for pass the data, etc., which is pretty time consuming. The way it works, there is two ways. The customer can sponsor the development by subscribing a certain amount per year or per month. And this is just to make sure that development happens, that a team is existing, that the development is financed. To take an analogy, this is just like F1 team in car industry. The F1 team is doing one thing, it's building car, technology in the car, and you have free way to invest in the teams. You can invest in money, so you make sure that your technology will be developed, and then you have access to the technology. This is what is offered by the open source way, by that, and subscribing, sponsoring my projects will offer you that feature. The other way in the way F1 is to buy support, like anyone. So you can buy support if you want, but this is by supporting, or you can buy customizations. And this is what is offered. So, as I say, we are building a platform to keep on-premise. On the left, we see our first POP, which is based on Vélizy. There is now two other POP, one in Valenciennes in France, and one in north of France, two in north of France, and one near Paris, south of Paris. More are coming. And on the right, you can see this is on my office. So this is the machine on-premise that index the data, etc., and that goes over the platforms, over the control plane, and check the things. So I already said that. So yeah, sponsoring the development, you subscribe, you ensure that your products will exist. You share the cost of development with others, so you are not alone to pay someone all the day, or to pay all day so something is developed. And you will have access to a forum where you can discuss things. Or you can buy supports, as I said. So wrap-ups. So what I built with Barrel is a Swiss knife to build a data platform that fits your need. And yeah, I still, like I said, think that Erlang is the right language for that. Orchestration, simple level for things. And now I think I have a sustainable business model for me, but also for my customers, so they don't have to always make sure, so they make sure that the product will be always there and under their control. And that's all for me.
Okay, thank you, Benoit.
Thank you.
We're going to be taking questions. Any takers? Online, in person? Chance online? No. We have one online. This seems like a really cool project, but I think it would be cool to read over the code. It may not be the simplest thing to follow. That's actually not a question, a comment that we're getting online. Yeah, but that will be it.
So the code is online, all the code is online. The code will be online next week or during the weekend. So it will be online on GitLab, and you can, if you join the website, which is actually back out in cost. But if you go on the website, you will have the update, and you will find all the source code and the way to to join the platform.
That's perfect. Thank you. Okay, let's wrap it up then. Let's give a round of applause to Benoit. Thank you very
Thank
much.
you.